Hey there, everyone. How are you doing? So today we're going to be looking at a cycle. Well, hopefully that's not as bad of a circle as I see it for you. No, it is a bad circle. Excuse me for a second. I'm gonna bring another paper. Oh, all the paper's been used. Oh, excuse me. Well, we have another circle. Well, that is better. It's just tilted. Okay, so in this circle, we are cycling with a ball. This is the center of rotation. This is your arm, for example, and we're rotating very fast. Now, where is the velocity vector? The velocity vector is tangent to the curve, so this is the velocity vector. Okay. Now, where is the real velocity? Well, that is where the velocity is pointing. Now, where is the acceleration pointing? Now, wait a minute. This is called uniform acceleration. And so if we measure the speed of this ball right over here, it is constant. Well, in my world it is. So it's moving at 10 meters a second. And so it's moving, and you say, oh my God, it doesn't have any acceleration. It doesn't have any change in velocity, right? Wrong. There is an acceleration in this circle. Well, how? The speed is constant. Yes, the speed is constant, but there is an acceleration. Well, how in the world is that happening? Well, there are many ways to understand this, but the easiest way is to say, okay, now, in this instant right over here, when the ball is going to move here, the velocity will move in that direction. Right? And the answer is right. So, the velocity vector was pointing here. Now, it is pointing here. Now, you can't just change the direction of your velocity. And so, because there is a change in the direction of the velocity, despite the fact that the magnitude of the velocity speed is constant, there is an acceleration that is acting. And since there is an acceleration that is changing that direction of the velocity vector, there has to be a force. So we have two new quantities. Okay? We have centripetal acceleration, and it is pointing towards the center, and we have the centripetal force, which is, as with acceleration, pointing towards the center. And so these are our three quantities that you have to understand very well. The velocity is pointing tangent to the curve, centripetal acceleration and centripetal force are pointing into the direction of the center of rotation. So now I want to emphasize something very important. In this instant, for example, we have the ball is rotating, and I'm going to cut this rope. So what will happen? Where will the ball move? Well, we're looking into this from an aerial point of view. So this is the table, and this is like, let's say, there is no example in my mind right now, but the ball is rotating in this direction. And so if I cut the rope in this instant, where will the ball go? The ball, when you cut the rope, will move in this direction. And so when you cut the rope, the ball or the to-be projectile or the rotating object will move in the direction tangent to the curve. That is a very important point to note. Okay? So there is something important that you should know. Now let's suppose that we have an object that is rotating, but instead it's in a vertical status of rotation. And so this is land, okay? And you're rotating and the ball is in this position right over here. Okay. And the rope is cut. And it's rotating in this fashion, so this in this way. And the rope will be cut. Where will the ball go? Well, we understand it's supposed to go to the tangent. Excuse me, my pen fell. So it should move like this, right? Well, wrong. It is correct in some sense, but it is incomplete. Well, how do we complete it? There's gravity that is acting on the object. And so that is how the ball will actually act. And so when you're solving a problem, you have to take into consideration how the rotation is actually going. Is it perpendicular or is it horizontal to the ground? Thank you, and see you in the next video. This was part 2. The next one will be part 3. Stay tuned.